Hello, welcome back to the stream. We're a week closer to finishing the GCSEs, but also a week closer to that paper 2. 9 days, just over 9 days really, or just under 10 days to go until paper 2, and then about another week, and then paper 3. So, if you didn't watch last week's live session, I went through some predicted topics from first class maths and advanced maths. So if you haven't watched that, I suggest going back and having a look. You can fast forward to the bits where I go through the exam boards for yourself. But I think that would be quite useful to, well, as a guide. Now obviously any topics can come up and they can put topics from paper 1 back on again, but it's very useful as a guide. So like I say, if you haven't already seen it, I'd recommend going back and having a look. On the stream today, I'm going to be going through trigonometry, right angle trigonometry, so SOHCAHTOA, and going through some problems with that, because that's one of the topics that first class maths predicted would be on AQA and Edexcel. Both high around foundation, but in terms of the predictions, less likely to come up on foundation than higher.
I don't know that.
Oh, Alexa, stop. There we go. Okay, so some starter questions there to have a look at. And I'll give you some time to think about those for a minute. And again, these are types of questions that were predicted to come up on the papers. So yeah, have a look, have a think, and like I said, I'll give us a few minutes just while people are joining to have a think about how you would go through, how you'd attempt these questions. And then before the end of the stream, I'll make sure I go through the question and thumbnail to see, you know, if you did have a go at it, if you got it right or not. You will need your calculators. I will say as well, I will try to try to do a stream the night before paper 2 and the night before paper 3. I will try to. So it depends on, you know, lots of different things. But yeah, I will try and set one up and try and do that. Because that's, well, somebody asked if that was possible, so like I say, I'll do my best to do that. And I'll try and do it for, I don't know, I'll sort the time out later on. But yeah, I will try and do that. Okay, give us another minute or so thinking about how you would do these questions, what you would do for them, and then I'll go through them. Like I said last week, I hope paper 1 went well. If it didn't, don't worry about it because it's done now. You just need to forget about it as best you can and move on to the next one. But if it didn't go as well as you wanted to, or you feel like it didn't go well, I would use that as motivation for revision for the next one, rather than stressing about it, worrying about something you can't change. Welcome to the people joining the stream this morning as well. I know it's a bit early on Sunday for some people to join, 10:30. You can watch it back afterwards if you want to, if you need to. Just check you can hear me. Yeah, it looks like it's all working properly, which is good. Okay, and as always, you know, if these are useful, if these are helpful, liking the stream would be very useful for myself. Just to get a gauge of actually what kinds of things do people like, what don't they like, what am I doing right, what aren't I doing right, what do you want me to do more of, kind of thing. Okay, I'll start going through these questions now, and again, like I said before, these are all taken from those predictions from first class maths, which are only predictions. There's no guarantees, so like I said before, revise everything, but you can, you know, if you want to, use it as a guide. Okay, so mean number of points per game. Now, what I want to do is actually work out the total zeros. So if I have 9 zeros, that gives me a total for the zeros of 0. If I have 11 tens, times them together, that gives me 110 as the total of the 10 points. And then 18 20s, I have to use my calculator for that. Right, actually I don't have to. 360. Double it and then times it by 10. And then 7 lots of 30, because frequency means how many. Okay, so 7 times 3 is 21, times by 10, 210. Now, that's my total of my zeros, total of my tens, total of my 20s, total of my 30s. To work out the mean, I want the total of all my numbers divided by how many numbers there were. So add up all of my individual totals, and I'll get the total of all of my numbers. 680. Now, for the total of all of your numbers, it's helpful to actually look at the question above your table as well, because quite often it will say, you know, I don't know, 60 games were played and these are the points per game kind of thing, and then it will tell you the total, so how many in the question. In this one it doesn't, so we're going to have to add up all your frequencies. 9 add 11 add 18 add 7 gives me 45, and then I'm going to do all of my numbers added together, so 680 divided by how many, which is 45. So 680 divided by 45 gives me 15.1 points per game. Now that's a recurring decimal, it doesn't say anything about rounding, so I do just want to check that I have done that right. 0 times 9, 10 times 11. I will check these all on my calculator. If you've got your calculator on these calculator papers, obviously, make sure you use it, even if it's for something relatively simple, because the last thing you want to do is make a straightforward make a mistake on a straightforward calculation. So it doesn't look like I have made a mistake there, which is fine. Yeah, so 15.1 recurring points per game. Now you don't have to. You shouldn't round this, because this is an average. It's not saying that's what we would expect to happen. You know, if it asked me maybe how many points I would expect a team to get, well, you would use the average, and they can't get 15.1, so you would probably round up to maybe 20, because you can't get 15 either. So if it was something like what would you expect a team to get, then that's a different question. If they're asking you what the mean number is, or the average, you don't have to round it, just leave it as it is. Okay, it takes 5 builders 4 days to build a wall. Work out how many days it would take 2 builders to build the same wall. So with this type of question, where it's asking you purely about the numbers and not about any equation, or you don't have to use an equation because it gives you an equivalence, write it out in terms of a ratio. So 5 builders 4 days. Okay, now we want to get to 2 builders, so I've left a gap there because you won't want to do that in one jump, because that's going to be a bit of an awkward number to times or divide by. So I'm going to get down to 1 builder first of all and find out how long it would take them. 1 builder, not builders. How to get from 5 to 1? Well, divide by 5. Now, if I reduce the number of builders, it's going to take longer. So this is inverse proportion. Okay, so if it's inverse proportion, you're going to use inverse operations. Instead of dividing on this side, I'm going to times, because like we've said, it's going to take longer. So times by 5, 20 days. Now to get from 1 to 2, I need to times by 2, so on the number of days, I'm going to divide by 2, and I'm going to get 10 days. Okay, so that's how long it will take, and that's the method I would recommend when it's purely numerical and you don't have to find an equation for proportion. But this is inverse proportion. Okay, something that would be direct proportion might be temperature and ice cream sales. If it's 10 degrees, sells, I don't know, 50 ice creams, how many would you expect to sell if it was 20 degrees? Something like that, which is, it's not quite direct proportion, because actually in that example it might be direct proportion between certain values, so maybe between like 10 and 30, but in actuality something like ice creams and temperature would be probably more closely related to like an exponential one, which you don't have to know about. But yeah, that's just an example anyway of something that could be direct proportion. Okay, next one is sequences, which is on the predictions from first class maths. So first 5 terms of a quadratic sequence. Now this is much more likely to come up on something like higher. On foundation, it's going to be, nth term of a linear sequence, not quadratics. Okay, so we've got to find an expression in terms of n for the nth term of this sequence. Now, quadratic sequences, it's the second difference which would be the same. So look at your differences like you usually would with a arithmetic sequence. So that is going down by 2, down by 4, down by 6, down by 8. Now the second difference here, how do I get from negative 2 to negative 4? Well, I take away 2. Take away 2, take away 2. So, at this point, what you would do is actually you halve your second difference, and that's going to be the coefficient of n squared. And quadratic means we're going to have something n squared plus something n plus something. Or minus, obviously, because you could add a negative number. So, we're going to have minus 1 n squared, and then we're going to work that sequence out. So, n squared is just, for your first term, 1 times 1, which is 1 times by negative 1. So that's going to be negative 1. 2 times 2, 2 squared, which is 4, times by negative 1 is negative 4. 3 times 3 for my third term, 3 squared, is 9, times by negative 1 is negative 9. And so on. So 4 squared is 16, negative 16. 5 squared 25, negative 25. Now what we want to do now, we've got that bit of the quadratic nth term. So we just need to take that bit away, so what we'll be left with is something n plus or minus something. Okay, so I'm going to subtract this from the original. So 5 take away negative 1 gives me 6. 3, if you're not sure, especially with the negatives, you've got your calculator. 5 take away negative 1, 6. 3 take away negative 4, 7. Negative 1 take away negative 9 is 8. Negative 7 take away negative 16 is 9, and at this point you can see what's going on. Negative 15 take away negative 25 is 10. So we just need to work out the nth term of this extra bit and then add it on to minus 1 n squared, and then that's it. We've got the nth term for the quadratic sequence. Now this is very straightforward because it's going up in ones. So that's 1n plus, now how do I get from, well, I'll phrase this a different way. For my first term, I would do 1 times 1, which is 1. But it's not 1 the first term, it's 6. So we've got to add 5. Now that will work for all the numbers as well. So 1 times 2 is 2, add 5 is 7. 1 times 3 is 3, add 5 is 8. So now we've got the two bits here of our quadratic nth term. We just need to add them together. So it's going to be minus 1n squared, or minus n squared would be fine, plus 1n, or again, just plus n, again would be fine, plus 5. And that's the answer, okay? So there's another way, well, there's other ways to do this, using, basically algebra. I'm not going to go into that now because that's not a method that I learned, and so that's not the way I do it. But there are other ways. So if you know another way and that works, that's fine. Okay, and then the last question we've got here is a functions question. And this is a topic which generally I think people struggle with a little bit in terms of, combining functions, also inverse functions, and substituting a number into a function. Now, this says f of g of x. So if I was to put brackets around the g of x bit, that might make it a bit clear, or more clear, in terms of what we need to do. We need to take our g of x function and we need to put it into f of x. Okay, because we've got f of x here, but we've changed the x to g of x. So take this g of x and plug it in here. So we've got f of g of x, which is the same as doing f of x squared plus 3, and that means just change your x in f of x to x squared plus 3. So we're going to get 2 times x squared plus 3 plus 1. And then obviously we need to rearrange that, not rearrange it really, expand it and simplify it is what we need to do. So 2 times x squared is 2x squared. 2 times 3 is 6, and then we've still got the plus 1 here, so we're going to get 2x squared plus 7, and then I'll just write down here fg of x. They make it confusing because they don't put the brackets around the g of x, so it's a bit more difficult to think about and understand what we need to do there. But if you remember that, like I say, it's not so bad. Okay, and that's just your answer then, f of g of x. Okay, right. The next thing, now we've done some of those warm-up questions, if you like, I wanted to show us this, and this is basically a GCSE Maths revision webinar by Casio, so basically for the calculator. Now, I will put the link in the description. You can see it on the screen as well. So there is this QR code, but it's not because of the printing, it's because of the picture I got this from. It's quite blurry, so I don't think you'll be able to scan that. So I'm going to put this link in the description after I finish this stream. If you're watching it back, it will already be in there. So education.casio.co.uk /student revision. Now this is on the 30th of the 5th, so that's 2 days time, 5 to 6 p.m. online, and it's going to be a free revision session by a qualified teacher and a calculator expert with a particular focus on how to use your calculator effectively and efficiently to answer actual exam questions. Okay, so that is very similar to what I'm doing here, but it will be especially useful I expect if you have the ClassWiz calculator, which is this one here, which is the one you've seen me use previously. It's the one with the ability to solve simultaneous equations and quadratics on the calculator. It's one that I would recommend buying because it will give you more confidence during the exam that actually you've solved the simultaneous equations right, that you've used the quadratic formula correctly. And it can also just solve linear equations, so it can solve things like 3x plus 7 equals 14. Okay. I haven't been using that one because I have used it at points, but I haven't been making sure I use it because I know quite a lot of people don't have the ClassWiz. So yeah, it's not always useful to show you that, and yeah, so I want to do it in a way that everybody can access it no matter what calculator you've got. But if you have got the ClassWiz, or if you have got the other calculator, the 85 GT or the 83 GT, I would recommend going and having a look at this session just to see the different things you can do on the calculator. And always free sessions like that will be useful, will be helpful. Again, education.casio.co.uk /student revision. I will put the link in the description after this live session finishes. Okay. Right, now on to some questions on trigonometry, SOHCAHTOA. Now the first thing I want to do is actually just go through a few things on here, on the whiteboard. Now, in terms of what people remember and in terms of what people know and the different ways of remembering this, some people may just remember the acronym SOHCAHTOA, which is what I used to remember when I learned this. So what that means, the S stands for sine, O opposite, H hypotenuse. So sine of your angle is opposite divided by, hypotenuse. So you've got that one. Then you've got cos for C is adjacent divided by hypotenuse. Okay, so you've got that one. And then T means tan is opposite divided by adjacent. Now, all this is really saying is that sine, cos and tan of these angles, or of an angle, is equal to these kind of scale factors, if you like, or relationships between the different sides of the triangles. So, again, I'll show you what those actually mean in terms of opposite, hypotenuse and adjacent. I'm sure most of us on the session or watching this back probably are aware of this, but just to make sure. So if I have an angle here, x, and I'll have some other sides that I know as well. I have to have at least one side, as well as the angle to work out another side, or if I've got two sides I can work out the angle. So if I have this angle, then my opposite is opposite the angle, so that's opposite there. The hypotenuse is always opposite the right angle, so that's the hypotenuse, it's the longest side, and the adjacent is the one that's left over, it's the one that's next to or connected to the angle which isn't the hypotenuse. Okay, now this labelling changes depending on where the angle is, because if I was to now put the angle up here, so if I was to put x here, then everything changes. So hypotenuse is still in the same place, but my opposite and adjacent would swap. So opposite x there would be down here, and then adjacent is over here. Okay, now another way of remembering this, and this is a way I've only found out recently in terms of how somebody writes it. I suppose you remember it the same way, but you write it a different way. So S and then OH, C and then SOHCAHTOA, and then TOA, and that just gives you a clearer way of the division. Now the final way that some people remember this is by using triangles, and actually the really good thing about these triangles is that you don't have to rearrange the equations. So for instance, with sine, x is equal to opposite over hypotenuse. If I wanted to figure out the hypotenuse, let's say, so let's say I had O, let's say O was 10, let's say x was 35. Okay, then to find out the hypotenuse, I'd have to times by the hypotenuse, bring it up here. So h times sine 35 is equal to 10, and then divide by sine 35 to get my hypotenuse. So I'd have to do that, I'd have to do some rearranging. Now, with these triangles, so I'll show you the sine one, because that's the useful one here. So, you know that sine is equal to opposite divided by hypotenuse. So opposite divided by hypotenuse, so sine has to go there. Now if you want the hypotenuse, like we did, you cover up the h and then you just do the opposite side divided by sine of the angle, which is what we end up with here. Opposite divided by sine of the angle. Whichever one you want, you cover that up and you do what's left. So if you want sine of the angle, cover that up, opposite divided by hypotenuse, and then because you've got sine of your angle, you've got to inverse sine. If you want the opposite side, cover up O, and you do sine of your angle times your hypotenuse. So that triangle has all the rearranging in there for you. Now obviously there are the other two triangles. So that's sine. Then we've got cos. So cos is adjacent divided by hypotenuse. So adjacent at the top, hypotenuse, one of the bottom ones, and then cos in the other one. Okay, and again works the same way. And then tan, very similar. So tan, well that's TOA, that's opposite divided by adjacent, opposite divided by adjacent, and then tan goes in the other one. So whichever one you want, you cover that up and you do what's left. So if it's on the top, that means you do the top one divided by, because you've got the line there, the bottom one. And if, so let's say you wanted the adjacent, if they're next to each other, you times them. So cos of your angle times your hypotenuse. The only thing you've got to remember is if you want the angle, cover up cos, adjacent divided by hypotenuse, and then inverse cos, because that would give you cos x is equal to adjacent over hypotenuse. If you want x, you've got to invert or inverse cos both sides. You can't divide by cos, because this isn't cos times x, cos is a function. So you end up with cos minus 1 a over h. Okay, and that will give you then the answer for the angle. Okay. Right, now that's the basics, and that's, it all kind of explained and out of the way, and at this point now we should all know, or at least be able to refer back to that to answer these questions if you weren't sure about how to do them before. Okay, just make sure this is nice and straight on the camera. Yeah, it's not too bad. Right. First question. Right angle triangle, x is a missing side. Use trigonometry to work out the value of x. Now, x is opposite my angle, so that's opposite, and then I've got the hypotenuse, which is opposite my right angle, and obviously I've got the angle. So I've got O and H. I don't need I don't want A. You could put A there. Don't need that, don't want it, don't care about A. So O and H, so sine, cos, tan, SOHCAHTOA. You need to identify which one you need. Now I've got O and H, so that's sine, because that's the only one with O and H in. So sine 20 degrees is equal to opposite, so that's x, over h, which is 10.2. How do I work out x? I need to rearrange this. I need to times both sides by 10.2. That will cancel out the divide by 10.2. And then I'll just have x is equal to 10.2 times sine 20. What you don't want to do is work out sine 20 first and leave it as a decimal, because then you'll end up with a rounding error. Okay. So calculator 10.2 times by sine 20, we get 3.48. Have a look back at the question when you work this out. Does it make sense? Is that plausible? Yes, it is. You know, if we've got something that's bigger than 10.2, bigger than your hypotenuse, that's not possible, and so we've obviously gone wrong somewhere. So yeah, do think about your answers in context. It doesn't say what to round it to either, so we'll just go with x is equal to 3.5 to 1 decimal place, and that's going to be centimetres. Actually, we don't need to put centimetres because we're just working out x. Centimetres is afterwards. Okay. Right, super. So that's the first one done. Next question. So to calculate the area of the triangle, first of all, well, that's nice and straightforward because that's just base times height and then half it. So that's 7.3 times by 4.8 divided by 2. 7.3 times 4.8 and then divide by 2, and we get 17.52. And then don't forget your units, that's going to be centimetres squared. Then it says calculate the angle x. So now we've got a scenario where we need to work out the angle. We've got the opposite side, because that's opposite your angle, and then the hypotenuse would be here. We don't need that, we don't want it, we want the angle, so that would mean that's the adjacent. So we've got O and A. SOHCAHTOA, that's going to be tan, so I'm going to use a triangle for this one. So TOA is opposite divided by adjacent, so opposite at the top divided by adjacent. I want the angle, so that's tan x I want. So cover up tan, I've got opposite, so 4.8 divided by adjacent, 7.3, that's got to be equal to tan x. Now I don't want to work that out yet, because I don't want to get a decimal answer and then basically get a rounding error at the end if I round it too early. So I'm going to leave it like that, and I'm going to do inverse tan of both sides. So that will cancel out the tan, and I end up with tan minus 1, 4.8 over 7.3. Okay, so x is equal to shift and then tan. Now again, I do always say this, but make sure if you're doing anything with trigonometry, sine, cos or tan, you have a D at the top of your calculator, because that means degrees, because there's other ways of measuring angles which you don't know about, you don't need to know about, but all you need to do is make sure the D is at the top of your calculator. If it's not, you're just going to get completely the wrong answer. You'll get a method mark as long as you write it down, but you'll get completely the wrong answer. Which again is why it's important that actually you check, does your answer make sense? Okay, inverse tan, what do we get? 33.3 to 1 decimal place. Degrees to 1 decimal place. Super, because again it doesn't tell us what to round it to. Right, next questions. Going to get a bit harder as we go through, as we progress through these questions, as they always do. Calculate angle BAC. Right, so I'll give you a second while I'm having a drink to think about which trig function we're going to use, sine, cos or tan. Okay. Right, so calculate the angle BAC. Now this isn't labelled on there, so the first thing you want to do is label the angle, and then you can label the sides, work out which one's which, because obviously if the angle's here or if the angle's here, it's going to change your labelling. Angle BAC, so the middle one is where the angle is going to be. You've just got to make sure it's trapped between B, A and AC. So it's this angle inside, not the angle outside, but why would it be when we're doing trigonometry? So we can call that X. Now that means that's the opposite. This is the hypotenuse, because that's opposite your right angle. Again, we don't want that, don't need it, don't worry about it. And then the adjacent has to be the other one, which we do have that. So you're looking for either you have that information, you either have the information, or you want that piece of information. So, you know, obviously we want the angle, so we're worried about that angle. We have the other two sides. Okay, so O and A. I've just done that once, that's tan. So that's going to be, again, I'll write out SOHCAHTOA, just to make sure which way around it is. Opposite divided by adjacent, so tan of X is equal to 37 over 20. So inverse tan both sides. X is equal to tan minus 1, 37 over 20. What does that give us? Doesn't say what to round it to again, which is helpful. Sarcasm, if you couldn't tell. With questions like this, why do they not tell you what to round it to? These are all past exam questions as well, you know. Yeah, anyway. 61.6, so we'll go to 1 decimal place again. 61.6 degrees to 1 decimal place. Okay, and the only more difficult thing there is actually putting your angle on the shape, on the triangle. Okay, and again, think about that. Does that make sense? Yes, it does. Okay, that could be 60. This is about double that side, so yeah, makes sense. You know, that angle, this angle is going to be about double that one. That's going to be 30-ish. That's going to be 60-ish, obviously. 90, yeah. So it does make sense. Okay. Next one is a different shape. Sorry about the crease here. Just the printing for some reason has gone wrong. Right. So, having a look at this question, use the diagram below, calculate the height of the tent poles required. Now this is obviously a tent, and that's my tent pole here. I've got an angle, I've got some measurements. What I can do, actually, before I go any further, if we're working out the height of the tent pole, it does say actually you may use either trigonometry or drawing in your answer. Now if you can use trigonometry, it's better because you know you've definitely got an exact answer if you've done it right. I think, obviously, if you do it right with drawing as well, you know, you've got the right answer. But I think I feel much more comfortable. I don't know about yourselves. I feel more comfortable doing it in terms of actual numbers and working with the numbers rather than trying to draw it exactly. And I think also the drawing would take more time. Right, now what we need to do here, first of all, is we need to make a right angle triangle, because at the minute this is split up into two trapeziums. We've got this height, so if we take or draw a horizontal line there, we're going to have a right angle here. Now that's going to be the same width there, so it's still 0.75. And that height here is going to be 0.5, so we can work out the height of there. So if we call that x here, we can work out that height. We've got a right angle triangle, we've got an angle, we've got a side, we've got two bits of information, we can work out a third. So we need to label the sides. Now that is going to be the opposite side, that's going to be the hypotenuse. Again, don't need that or want it, so we need the adjacent, that is. So again, it's tan. I'll use what I've written down up here, SOHCAHTOA. Tan is opposite divided by adjacent, so tan 30, tan of my angle, is equal to opposite 0.75 divided by adjacent, which is x. Now this is a scenario where the triangle is a bit more helpful because you've got to do a bit of rearranging here. You've essentially got to swap the x and the tan 30. Those will switch in the end. Times by x divided by tan 30. You end up with x is 0.75 over tan 30. Now this could have been a non-calculated question because tan 30, we should know that as an exact trig value. But it doesn't matter, it could be either as well, because I expect they wouldn't expect, I mean they could expect, because that's 3/4, 0.75 divided by again another fraction. So they could have asked you to do that, but you're not going to be able to give you know, maybe an exact answer, because well, let's say you're going to end up, I'm sure, with root 3's. So 0.75 and then 3/4 divided by something including root 3 is not going to be very nice. Tan of 30 is, 3 root 3 over 4. So you've then got to add on to that your 0.5. So that's 1.299. 1.299 dot dot dot. I'll put the dot 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 because I'm going to leave that on my calculator because that is this height here. I've now got to add 0.5 to get the height of the tent poles. So 1.299 dot 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 add 0.5 gives us, so just answer plus 0.5 and we get 1.799, so 1.8 meters to 1 decimal place. Okay, so that's that question solved. The main thing with that question is making the right angled triangle. That's why that one's slightly more difficult. You've got to be able to spot, that's what you need. It does say you need trigonometry. You can use trigonometry, so that's kind of a hint that you have to make that right angled triangle. But with other questions, it might not say that. You just have to notice that you can do that. Okay, next question, we are looking at some bearings here. Now, bearings are an interesting type of question because obviously to draw a bearing you need a protractor, but actually sometimes, and depending on the wording of the question, it will be nothing to do with a protractor or the angle or finding the angle. It will just be to do with understanding what a bearing is and then using, some actual calculations. So it's going to be exact calculations, exact answers, rather than giving you a range if you were to draw a bearing. Okay. So it says A, B, C and D are 4 towns. B is 25 kilometres due east of A. So I'm going to get my ruler. So B is 25 kilometres due east of A. So I'm going to draw a straight line there. That's 25 kilometres. C is 25 kilometres due north of A. So C is 25 kilometres up here. Okay. Now if I join those two up, I'm going to end up with what must be a right angled triangle, because thinking about directions, I've got east, which is absolute left, and then I've got north, which is, absolute up, if you like, vertical. So they must be perpendicular, so there must be a right angle there. If you then notice, before I go any further, and it's always good, in my experience, in my opinion, to work things out as you're going. Because what will happen otherwise, or quite often happens, if you read the whole question, you can get what's called cognitive overload. You'll be thinking about too many things at once, and then that might mean you don't even know where to start, or which piece of information to use first. So if you can do something as you're reading through the question, do that, it will make your life easier. Now I've got a right angle here. These side lengths are equal, isosceles triangle. So if I do 180, take 90, there's 180 degrees in a triangle, divide that by 2, I'm going to get 45. So these angles here are 45, both of them. Okay, I could also work out, because this is a right angled triangle, the length from C to B using Pythagoras. So let's write it as B to C is equal to 25 squared plus 25 squared square rooted, which is equal to 25 squared add 25 squared, 25 root 2. Now I might need that, I might not. 25 root 2. Okay, that's fine, so that's done. Now let's read the rest of the questions. Can't do anything else at this point, I don't believe. So D is 45 kilometres due south of A. So that's 45 kilometres down here. It's 45 kilometres. And then I can, again, that's going to be a right angle here. I can make another right angled triangle like this. And again, I can't work out the angles here because they're not isosceles. So I'm going to have to do some trick to work out those angles. But I can work out the length from B to D using Pythagoras again. So B to D is equal to the square root of 25 squared plus 45 squared. 25 squared plus 45 squared, we get 5 root 106. Write down the exact value because I don't want to round it. I might need it, I might not. I've got everything I could work out there. I could work out these angles. I could do trig with that, but I want to see actually which one of these do I need, because there's a very high chance I only need one of these angles. And to be honest, once you've worked out one, just do 180, take 90, take your angle, give the other one. But let's see actually what we need at this point, because that's a good amount of work to work out those. Work out the bearing of B from C. Okay, the bearing of B from C. So I need to go from C, draw a north line at C, so just carry that line straight up. So that's my north line. Now, this is not to scale, so we can't use a protractor to actually work out this angle. We can work it out exactly. Now, that's 45 from the north line below. We need to measure clockwise from north. So, across there, that's going to be 90 from north to east. And then east to this line, well, we know east to south is 90, and we've already got 45. So that's got to be 45. That's 90. 90 add 45 is equal to 135 degrees. Now, see how actually working out that was 45 degrees made our lives a lot easier, and if I just read that question and not kind of worked that bit out or realised that, then that question would have been a lot more challenging than it was. Calculate the bearing of D from B. Okay, so now we need to go from B, so I need a north line here, and it doesn't matter if this isn't quite north because it's theoretical at this point. You know, I just need to work out some angles around here, and then I can do that and kind of subtract them and work it out. So I need to work out this angle here. Right, now, there's a couple of ways I could do this. I could split that up into, well, that's 180 plus something. So I could work out this angle and take it away from 90, because from B going west, between west and south would be 90 degrees. And if I can work out this angle in my triangle, take it from 90 away to this one, and then add it to 180 over here. Bearings always go clockwise from your north line. Right, so actually let's work out this angle of the triangle. Now, opposite would be here, and then adjacent is 25. Hypotenuse would be this one. I'm going to cross out the hypotenuse. I'm going to use opposite and adjacent again. Call this angle in here X. It's a bit, you know, small, this diagram. I think actually if this was full size, you know, on the exam paper, it would have been a bit bigger. You'd have a bit more room to draw it. And I think actually you did get two diagrams, two A, B, C's and D's, which you could have used. So there would have been less information on there, a bit easier to understand. But then working out this angle in the triangle here, A, B, D. So opposite is 45. Opposite divided by adjacent, 25, is equal to tan of my angle, so tan x. Inverse tan both sides, so I'll do it over here. X is equal to tan minus 1 of 45 over 25, and that gives us 60.94, so 60.945 ... So that's this angle here, that's where the X is. So I need to do 90, take away that to get this bit. So 90, take away 60.945 ... 90, take away my answer is this, 29. So that bit there is about 29 degrees, about. Now, because I measure from the north line for, or you have to measure from the north line for a bearing, and you go clockwise, it's 180 because that's a straight line, plus the angle I've just worked out. So 180 plus 29.05 ... is equal to 209.1 degrees to one decimal place. Notice there how I never rounded any of those numbers. Don't round it until the end. I know I say that a lot, but make sure you don't, because that's a mistake that people make all the time. Okay, excuse me. It's hard talking for so long. You get out of breath, especially in this weather as well. It's very hot. Right, next question. This one is to do with ratios I've noticed down here, because I've got this. The diagram shows triangle ABC. ABC. Okay, so talking about that one. D is a point on AB such that DB is 6 centimetres, BC is 10 centimetres, so I can use Pythagoras to work that out. Angle CAD is 30 degrees and angle BDC is 90 degrees. Right. Work out the ratio length of AC. So I need this one to the length of DB. So this one. So I need to put them in a ratio. So I basically have got DB already. I just need to work that one out. I've got an angle. I need another side in this triangle. If that's a right angle, that must be a right angle. I need another side here to work that out. But I've already said I can use Pythagoras to work out CD. And then we can use trig, can't we? And then we can do a ratio. Okay, so we've got, again, actually we're using Pythagoras. It doesn't matter, we don't need to label the triangle. I just need to do the square root of 10 squared minus 6 squared. It's minus because I'm using the hypotenuse, working out a shorter side. So, square root of 10 squared minus 6 squared is 8. So that's got a length of 8. Now, again, this could have been a non-calculator question, or could be calculated, doesn't matter, because I need to know sine, cos and tan 30 degrees, or you would have had to know that. So they could have put this on a non-calculator one, but equally, it doesn't matter if it's calculator, same process, just slightly different numbers. Just watch out for the rounding errors. Now, I've got an angle. Now, that is the opposite, okay, and I want to work out the hypotenuse. So, finally, it's a different one. It's not tan anymore. SOHCAHTOA. When you get a trig question, make sure you write some form of this down, so you've got that as a reference and you're not just doing it in your head and then you've got more room for errors, okay? Do write some format of that down, whether it's the triangles, whether it's this format, whether it's just SOHCAHTOA, whichever one you use. Okay, so I've got opposite and hypotenuse, that's sine. So sine 30 is equal to opposite, which is 8, over hypotenuse. Now you're going to times by the hypotenuse and divide by sine 30, and essentially what's going to end up happening is they will swap places. So my hypotenuse is 8 over sine 30, and so the hypotenuse is, well, let's work this out, 8 divided by sine 30, 16 centimetres. So now we need to put these in the ratio. So A to C has to be on the left. So it's going to be 16 to dB, which is 6. Need to simplify it, so we need to divide by a number that we can divide both of them by. So 2. Half 16 is 8. Half 6 is 3. So that would be my answer, 8 to 3. Okay. Right, now also if you did get this question and it had decimals in it, you can't have, usually they wouldn't want decimals, unless it said in the form 1 to n or n to 1, you wouldn't want decimals in a ratio. Unless, like I say, it said write it in the form n to 1 or 1 to n, then you would end up having decimals in there. Okay, we've got about 10 minutes left, so what I'm going to do, I'm going to show you these questions and I'm going to move on because I want to actually have a look at some of these harder questions. Okay, so there's those questions you can have a go at if you want to. There's these questions which are slightly harder, and I do need to make sure I go through the question that we had on the thumbnail. Now, I will just need to quickly print that out, I think, because I haven't got that. So, what I will do, I'll give you a minute or so to just have a look at this question here, or this question down here, either or, before I go through them. Okay. Okay. Have a think about what you would need to do. You don't necessarily have to work it out, but actually what is it sine, cos, tan? What do you have to do to get to the answer? Okay, right, let's start going through this then. So, work out the size of angle KLM. So you've got to work out this angle, so I'll call that X. First thing is identifying that angle. It says give your answer correct to 3 significant figures. Hopefully you can still hear me above the printer. So, we're going to work this angle out. We've got one side. If we're working out an angle, we need 2 sides. If we're working out a side, we either need the other 2 sides or we need a side and an angle. So again, I've got a right angle here, I've got 2 sides. I can use Pythagoras to work out this side, 4.5 squared plus 7 squared, and then square root it. That's going to give me probably not a nice number because I'm squaring 4.5. So that's going to give me 8.32 to 2 decimal places, sorry. Just closing this, making sure the stream is still running as it should do, and the time's still counting out. It is good. Right, so 8 point. Oh, actually, I can write that as in the exact form: root 277 over 2. Now, if you can write it in an exact form, do that, because that will mean that you don't have to write in all the decimal places, or you can actually just get rid of the number off your calculator screen. Okay, next we need, for this triangle here, the KLM triangle, opposite, because that's opposite my angle, and then the hypotenuse, because that's opposite the right angle. Okay, so, again, SOHCAHTOA, make sure you write that down. We're going to need to use, we've got the opposite and the hypotenuse, sine again. I don't think we've used cos yet, have we? So, opposite, which is root 277. So sine of x is, and you can write a fraction in a fraction, don't be worried about that, root 277 over 2 over hypotenuse, which is 15. Now to work out the angle, we need to do inverse sine. So instead of plugging this in and getting an answer, why don't we do it all in one go? So x is going to be equal to sine, or inverse sine, of root 277 over 2, all divided by 15, and then we'll get that answer. So I'll show you on the calculator. So fraction, so that's the original fraction, then we want another fraction on the top. So fraction again now, square root 277 over 2, press down again, we get 15. I forgot to do the inverse sine, so I'll go back. So if you, go back to the start, shift, sine. Okay, I need to go scroll all the way through back to the end now to put the other bracket on. That gives us 33.7 to 3 significant figures. Okay, and that's it, we're done. Now the next one is to do circle theorems. They've mixed some stuff up here. They've mixed circle theorems in with trigonometry. It says, calculate the area of the circle. A, B, C, and D are points on the circumference of your circle. Okay, now, BD is the diameter of a circle. So that's the diameter. Now with my circle theorems, if that's the diameter, then I know that this angle on the circumference is a right angle. Now also with my circle theorems, I also know that, excuse me, with angles in the same segment from the same chord. So if you notice, if I go from this chord here, DC, angles on circumference from the same chord are equal. So I can go from the 2 points D and C to B on the circumference, or I can go from D and C to A on the circumference. Those 2 angles have to be the same. And quite often that looks like a kind of bow tie shape. If you take out that line, it can look like a bow tie. If I was to turn it round or tilt your head, you can kind of see it. Sometimes it looks more like a bow tie than others. It's quite a sharp bow tie, that one. Right, calculate the area. Now, I've got that angle there. I need a right angle triangle to use my trig. So if I forget about this line, and if I forget about this line, so I'm just going to look at, just grab a highlighter to help. I'm just going to look at this triangle here. Right. Okay, I'm just looking at that triangle. So I've got an angle, I've got a side. If I can work out BD, that's the diameter, I can then get half, I get the radius and then work out the area. And I can do that because I've got a side and I've got an angle. So, my right angle's here, that's the opposite, sorry, that's the hypotenuse. I'm confused with the O there. And then opposite my angle, that's the opposite. So again, it's going to be sine, opposite and hypotenuse. But still write out the acronym just so you've made sure. SOHCAHTOA. So I've got opposite, I've got hypotenuse. Sine 28 degrees is equal to opposite, so 6.4 over the hypotenuse. And just like we did with the last one, times by the hypotenuse, divide by sine 28, what will end up happening is those two things will swap. So you end up with h is equal to 6.4 over sine 28. And what does that give us? Let's have a look. 6.4 over sine 28 gives us this number. Now I want to keep that on my calculator, I don't want to round that. 13.63 dot dot dot. That is BD, that's the hypotenuse of that triangle, which is also the diameter of the circle. So the radius is equal to 13.63 dot 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 divided by 2. Excuse me. Divide that by 2, we get 6.816. Again, keep that on your calculator. 6.816. Don't get a rounding error. Now we need to do for the area of the circle, pi times by the radius squared, which is going to be pi times 6.816 dot 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 squared. So the area is going to be shift pi times by answer squared, 145.95 dot 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 whatever. Let's round it to, if we go to one decimal place, it's going to round up. 5 takes the 9 to a 10, so it still makes it 146. Let's go to three significant figures. That's probably the best way, isn't it? 146 centimeters squared, 3SF. Okay, so that's to do with circle theorems, and you got some trig in there as well. All right, and it might be useful to use a highlighter like I did there, just to highlight actually which lines you're thinking about and where your shape is, because if there's more lines like there were on there, it can be a bit confusing. Okay, right, I will show you the other questions I had printed off, some of these harder ones, or more difficult ones for you to have a look at or think about, and then I will do the question that I put in the thumbnail for you. So, there's this one, and I'll briefly just go through what you need to do. Angle BAD, BAD, so you need to work out that angle. You've got trapezium, split it up into a right angle triangle and a rectangle here. Then you can work out this little angle and add it to 90 degrees. Okay. This one is quite a difficult question because it's finding the angle between this rod and the base of the tin. Okay. So you would end up having your triangle there, but because it's in 3D, it's a bit difficult. The tin is on a horizontal table. AC is the diameter, so draw that in. B is on the top edge of the tin. BC is vertical, so that's going straight up. So you know that's straight up, you know that's straight across. So that must also be a nice triangle with, it's got to be a nice vertical triangle rather than a slanted one. The radius of the base of the tin is 5, so AC has got to be 10. The volume of the tin is 1178, so then you can then use that to do reverse volume, give you the height, and then you can then find this angle. So reverse volume, undo the volume, so the volume of that tin would be pi times r squared times by the height h. Plug in your volume, plug in your r squared, 5 squared, divide by pi r squared gives you a h, then use trig to work out the angle in that triangle. Okay. And then the last couple of questions, which again a little bit tricky. OAB is a sector of a circle, centre O. OA is 6 and AX is perpendicular, so you've got your triangle here. Area of the sector OAB is 6 pi. So remember, you've got, I'll call that theta, angle over 360 times by pi r squared gives you the area of a sector. So again, you're going to have to do the reverse process to work out, you've got your radius is 6, you can then work out the angle, excuse me, oh sorry, no, what does it say, the area, yeah, so you can then work out the angle because you've got the area, and then you can show that the height of this, because you've got the angle and the hypotenuse, to get the opposite side using trig is 3 root 3, okay, that's what you need to do with this one. With this last one, ABC is an isosceles triangle. The sides of ABC are all tangents to the circle radius 6. So you've got a radius there, you've got a radius here, which is 6, you've got a radius down here, which is 6. Now, those two tangents meeting a circle meet at a point will be equal length. And I could do another line up here. You've got a right angle triangle. You've got one side is 6, 70, 70. Which means that whole thing is 40, which means each one of those little ones is 20. You've then got a right angle triangle. If I draw the line, I'll make it a bit easier to see. You've got 2 right angle triangles here. Okay, you can then use that to work out that height from B to O, and then add on your 6. Okay, and then when you've got the full height of this, you can then also work out with a right angle triangle here and split that up into 35 with your right angle, work out the length of this, double it to get the area of your base, times by the height and half it, okay? But because I'm running out of time, I'm not going to go through all of that question. I've just kind of explained out what you would need to do. I'm going to go through the question I put on the thumbnail. Okay, so we've got this question. Ignore the writing on the back. I've had to reuse some older paper that I've used before. We need to work out x. Now we've got here 49 degrees and 16. We've got an angle and a side. If we have another side, we could work out that angle. We don't know that's a right angle. Right, so if I use my trigonometry here, so I've got, that's the opposite, which I'm going to work out, and then I've got the adjacent here, because that's got to be the hypotenuse, and I don't want that. So I've got opposite and adjacent, so again, if we write SOHCAHTOA, okay, so opposite and adjacent, opposite divided by adjacent, so I'm going to use tan, so tan of 49 is equal to opposite divided by my adjacent, which is 16. Okay, and then from there what I need to do is times both sides by 16. Let's cancel out the divide by 16, and you get 16 tan 49 is equal to the opposite. So again, I need a calculator to work that out. Where have I got the calculator? Over here. So 16 times tan 49 is equal to 18.40 dot 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 18.40 dot dot dot. I can then use for this one the sine rule. So you might be familiar with this. This is basically trigonometry with non-right angle triangles. So because I don't know that's got a right angle in it, I'm either going to have to use sine rule or cosine rule, or if you want the area, half AB sine C. So this divided by sine of this is equal to this divided by sine of this. So 18.40 dot 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 divided by sine x is equal to 20 divided by sine 35. Now a useful thing to know with the sine rule is you want the thing you're working out to be on the top. So what I can do is I can flip both of these. There's a long-winded way of why that works. Times by sine x, divide by sine 18.4, times by sine 35, divide by sine 20. Essentially, you just need to remember or know, or be helpful to remember or know, that you can just flip both of these to make it more useful. So, if I flip both of them, I get sine x over 18.40 ... is equal to sine 35 over 20. You want the bit you're working out to be on the top because that's going to make your life a lot easier. Now times by this 18.4, so sine x is equal to sine 35 over 20 times by this 18.40 ... that we worked out before. And then to work out x, I need to inverse sine both sides. So x would be equal to sine minus 1 of sine 35 divided by 20 times by 18.40 ... the answer that we worked out way back here. So now I'm going to use my calculator to work that out. I'll put it where you can see my calculator, hopefully. There we go. So inverse sine, shift inverse sine, and then I want fraction, I want sine again, 35 divided by 20 times by, now actually I'm just going to delete all this because I want to check my answer button is that. Let's have a look. Yes, it is. Good. So do it all again. Inverse sine, fraction, sine 35 divided by 20 times by answer button, close bracket, press equals, and this will be my answer. So 31 points, doesn't say what's around it to, 31.9 degrees. And that's to 1 decimal place. Okay, so if you did try this question before and you got that, well done, because that was a tricky one, you know, especially with the sine rule in there as well. Got to do two things, but also got sine rule. Okay, I hope that was useful, people that are watching. If it was, like I always say, like the video, because that lets me know that actually it was useful, but also seeing that a few of us have stuck around for the whole thing near enough tells me as well that it was quite useful. Excuse me. Also, if you did want to support the channel, there is that QR code in the bottom left to buy me a coffee, or there's the link in the description. Like I said earlier on, I will be trying to do a live stream the night before the exam as well. I'll do my best to do that, but it might not be possible. I will do my best though, so just, you know, stay tuned for that and make sure to check and have a look to see if that is on. If it is on, I will be doing it at 8 o'clock. Okay, let's say, so check at 8 o'clock. If it is on, that's the time it'll be on. Okay, right. Like I say, I hope that was useful. Enjoy the sunshine while it lasts. Good luck with all the rest of your exams. You know, enjoy your half term while you're also revising as well. Okay, see you next week, next Sunday, 10:30. Bye bye.